So that's what's new. That's what's shocking, is that of all the species, it's dogs that are showing a couple of abilities that are really important that allow humans to develop culture and language.
It's not surprising that dogs share characteristics with humans. After all, we've evolved alongside each other for more than 15,000 years. There are now some 80 million dogs in this country, more dogs than children. But for all the playing and petting, the companionship, we still know very little about their brains. Dr. Greg Burns, a physician and neuroscientist at Emory University, has studied the human brain for more than 2 decades. But 3 years ago, questions he had about his own dog inspired him to start looking at the canine brain.
It started out with the desire to know, really, what does my dog think of me? I love my dog, but do they reciprocate in any way? When they hear you come home, they start jumping around. Is it just because they expect you to feed them? Is this just a scam by the dogs?
Are dogs just big scammers?
Yeah.
To try and answer that question, Dr. Burns is doing something scientists have had a difficult time with. He's conducting brain scans on dogs while they're awake and unsedated. Inside the fMRI machine, they're trained to stay completely still.
How hard is it to get a dog to do this?
This represents probably about 3 to 4 months of training, and so most of the dogs take that long.
What's around Tigger's head here?
The scanner makes a lot of noise. It's quite loud, and because dogs' hearing is more sensitive than ours, we have to protect their hearing just like ours. So we put earplugs and earmuffs and just wrap it all to just keep it in place.
Okay, now you go up.
Tigger certainly knows the drill.
That's good.
Once in the machine, he lies down and doesn't move. These scans are giving Dr. Burns the first glimpse at how a dog's brain actually works.
So these are slices of Tigger's brain that you're seeing?
Yeah, exactly. So we're slicing from top to bottom. We analyze them later to see which parts increase in response to the different signals.
While in the scanner, the dogs smell cotton swabs with different scents. First, the underarm sweat of a complete stranger. Next, the sweat of their owner. As Dr. Burns expected, when the dogs sniffed the swabs, the part of their brain associated with smell, an area right behind the nose, activated. It didn't matter what the scent was. But it was when the dogs got a whiff of their owner's sweat that another area of the brain was stimulated, the caudate nucleus, or reward center. Dr. Burns believes that means the dog is experiencing more than the good feeling that comes with a meal. It shows the dog is recognizing somebody extremely important to them. It's the same area in a human brain that activates when we listen to a favorite song or anticipate being with someone we love.